Hi, hello, and welcome back to this series on AWS networking. And in this lesson, we are going to discuss about AWS Security Groups and network access control lists. So in this session, we will explore the concepts behind security group and network access control list, how they work and how they can be used to enhance the security of your AWS environment. So security groups are virtual firewall that control the inbound and outbound traffic for an EC2 instance. As depicted by the red perimeter here, the security groups act as a virtual firewall for your instance and it controls the inbound and outbound traffic. It is basically a set of rules that you define to allow or deny the traffic that can flow in and out of your instance or instances. So a security group can be applied to an instance in any subnet, or it can be also applied to a group of instances or in different subnets as well. A security group is created in a VPC scope. So any instance that you launch within that particular VPC can be associated with a security group that you have created within that VPC scope. So this is a point to remember. In addition to that, it is to be noted that the security group rule applies at an instance level. This is different to how the rules apply in a network access control list, which we will look at the next part of this lesson. In addition to that, it is also to be noted that a security group by default is deny all traffic, which means that if you want to allow a certain type of traffic into your EC2 instance, you will have to explicitly allow it by adding a particular rule in the security group. So for example, if I have added here HTTP traffic over port 80 for all IPv4 address range, and similarly for all IPv6 address range, and I have opened SSH port over 22 for all IPv6 address range, it means that these rules are explicitly allowing and denying any kind of traffic into your instances that are associated with this security group. Now let's have a quick look at the security group features. So first and foremost, it controls the inbound and outbound traffic for the associated EC2 instances. So you could specify the type of traffic that is allowed and the source or the destination of that particular traffic. It is stateful in nature, and what it means is that if we are allowing an inbound traffic or we are defining an inbound rule, the traffic corresponding outbound traffic is also automatically allowed. So for example, if we are opening HTTP traffic, inbound traffic via port 80, we don't need to explicitly define that rule in the outbound rules. The security group will automatically remember to allow the outgoing traffic over that port. Next feature is flexibility. So security groups are highly flexible and they allow you to specify rules that control traffic based on protocol, port number, source or destination IP address, or a CIDR block. So this allows you to create very specific rules that you require to allow the traffic that is necessary for your application to function. Then security groups allow granular control of traffic at the instance level. So you can apply security groups to an individual instance or a group of instances, which makes it easy to manage the security across your infrastructure. For example, suppose if you have 10 EC2 instances which are running your application and you are horizontally scaling these EC2 instances, and all these instances, these need to connect to a MySQL RDS instance. So we can define a security group that explicitly allows traffic only to this MySQL instance. And every new instance that you are going to create as part of your scaling can be associated to this security group. And in return, in this security group, you are adding an inbound rule for the MySQL RDS instance. So wherever you are going to apply this security group, that new instance that is getting created as part of your scale up activity will automatically gain access to the MySQL database instance. So this way it makes it easy for you to manage the security rather than going in and for each instance defining the rules. So you just define it in the security group and then you just attach the security group wherever you want these rules to apply. Then next property is dynamic. So security groups are dynamic and they can be changed at any time. You can add or remove rules in the runtime. You can modify existing rules or apply security groups to a new instance as your infrastructure evolves. And all these changes are real time. You don't need to wait for these changes to take effect, like shutting down or rebooting your instances or detaching and reattaching the security groups associated with your EC2 instances. The next property is integration with other AWS services, whereby security groups can be integrated with other services such as Amazon RDS and Redshift in addition to the Amazon EC2 services. So this allows you to create a consistent security posture across your entire infrastructure involving various services that support security groups. Okay, so now let's understand the security group rules and its components. So the very first component is an inbound rule that controls the type of traffic that can reach an instance. So it can define what kind of traffic can flow into your instance. Then we have outbound rules, which can define the type of traffic that can exit your instance or leave your instance. And when we are defining these rules, we have something called source, which is associated with the inbound rules. And then we have destination, which are associated with the outbound rule. So inbound rule, because it is coming from somewhere, coming from some other instance. So the IP of the other instance becomes the source, right? In other cases, if it is a public facing internet that you're talking about, then the IP of the requester becomes the source. So you can define which source you want to allow. So it could be a single IP or it could be a range of IP addresses. You can open to all address ranges, like as you can see here. Suppose, for example, you have a internet facing application and for that you want to open the incoming traffic for HTTP. So this rule defines that you are not restricting it to any particular IP or IP address range, rather than you are allowing all IPv4 addresses to come in via port range 80 into the EC2 instance that is associated with this security group. Apart from the IP addresses, we can also attach security group ID as source or destination for the inbound and outbound rules. And what it means is that, suppose, for example, I have a security group A, and this security group A has been associated with 10 EC2 instances. And since I have the security group A as a source in my inbound connections, all these 10 EC2 instances which are associated with security group A are now allowed for an inbound connection from these 10 EC2 instances, because they become the source. And source why? Because they are associated with security group A, which I have defined as the source. We'll look at it in detail in the next slide, but on a high level, just try to understand this for now. That if I have 10 EC2 instances which are associated with a security group A, And if I have just taken that security group and added to my inbound rule here, what it implies is that the incoming traffic from over, say, port 22, as in this case, all these 10 EC2 instances will be allowed to SSH into the EC2 instance where this particular security group is going to be attached. So let's keep it at that for now for a high level understanding. And this security group can be applied for inbound as well as outbound rules as well. Now, the components of a security group, as we discussed, we have protocol where we define the protocols. We have the port range where we can either define one single port or a range of port. Like for an example, we can define 7,000 to 8,000. So we can either define one port or we can define a range of port. And then, as discussed, we can define the ID of a security group in the source or destination. And also in the source or destination, we can either define a single IPv4 address or IPv6 address, or a range of IPv4 address denoted by a sided block notation like this. And one important thing to remember here, and that is a very important aspect, that when we are defining the rules, don't just define the IP. So when you are defining a single IP, you follow it with a /32 prefix. What /32 prefix means is that it is denoting one host only. So you will always have to remember that whenever you are trying to define only one IP address and not a range of IP address in your source or destination, you have to add the prefix length of 32, so that because otherwise it will not accept the entered IP address when you try to save that particular rule. So this is an important thing to remember. So apart from that, we saw that we have descriptions. So this is an optional field which will help you define what kind of rule this is and for why you are adding this rule. All those descriptions can be recorded here. Now moving on, since we have discussed around security groups being added as source or destination, this is called security group referencing in context of security groups. Okay, and it is one of the key aspect of security group best practices. So when we are specifying a security group as a source or as a destination for a rule, the instance can communicate in a specified direction, inbound or outbound, using the private IP addresses of the instances over a specified protocol and port. So what it means to say is that suppose we have 5 EC2 instances which are associated with a security group 1. Now I have a EC2 instance which is associated with security group 2. And what I am doing here is that for security group 2, I am defining source as security group 1, and in the protocol I'm saying I'm allowing SSH over port range 22. So what this means to say is that all these 5 instances which are associated with security group 1 will have SSH access to this EC2 instance, because this EC2 instance has been associated with security group 2, for which in the inbound connection you have defined source as security group 1, and with security group 1 we have all these 5 instances associated. So all these 5 instances will gain SSH access to this instance. This is called security group referencing. So both security group must belong to the same VPC scope. So when you create a security group, you are asked to define under which VPC you are creating this security group. So both security group 1 and 2 here needs to be from the same VPC. And then remember that whatever rules you have defined under security group 1, they are not actually added to security group 2. It is just giving access it's just referencing the private IP addresses of these associated instances as a source, but it has nothing to do with the rules that are defined under Security Group 1. This is one important aspect to remember. So whatever rules, inbound rules or outbound rule you configure under Security Group 1, they do not apply to Security Group 2. It is only and only referencing these EC2 instance IP addresses as the source, and that's it. And then we have seen the inbound and outbound rules, like how it is implying here and then giving access to the instances here. Now moving on, let's understand the security group referencing with a real world example, which is a best practice architecture for deploying your web application, internet facing web application. So here we have elastic load balancers, which act as a proxy server between the internet traffic and our application servers, which are lying in the private subnet. And then we have database also in the private subnet. So we have the application load balancers, which are sitting or associated with the ELB security group. This security group is allowing inbound connections from internet, and it is allowing all IP address, IPv4 address range over HTTPS. So that's how the traffic is coming in into these appliances, these EC and these elastic load balancers. Then we have our application instances, which are associated with app security group, which allows the security group of ELB as a source over the HTTP and HTTPS protocols. What it means that it is allowing ELB security group as the source in the inbound connection. So what it means that these two application load balances are being considered as the source, or the private IP addresses of these two elastic load balancers are being considered as the source for the inbound connection in this app security group. So it implies that the inbound traffic or the inbound HTTP and HTTPS traffic from these load balancers would be able to enter these two application instances. And then we have the DB security group, for which the inbound connection permits security group of the app over DB ports, whichever DB port may apply to these database instances. But it is allowing the security group of the app. That means app security group is being referenced as a source for DB security group. And what it implies is that these two DB instances will be allowed an incoming traffic over the DB ports from these two instances, since these two instances are associated with app security group, and the app security group is being referenced in the inbound rule for DB security group as a source. So this is a real world implementation, as you can see here, of the security group referencing, and this lays down a very secure layered security in this best practice secure architecture to deploy a web application, internet facing web application. So here you are not exposing your application directly to the internet, and you are placing it in a private subnet that they don't acquire any public IP or elastic IPs. These instances are always running on private IP, but at the same time the internet traffic or the internet request is getting routed to them via the elastic load balancer, and from that layer itself you are starting to filter the traffic. You are only allowing HTTPS connection into this elastic load balancers, and then the second level of filtering you are doing on the app security group, wherein you are only allowing HTTP and HTTPS traffic from the instances or the appliances that are associated with security group, ELB security group. So the appliances are these two these two application load balancers. So only HTTP and HTTPS traffic originating from these two appliances will be allowed to enter these two instances. Now, on the database layer, again, you are allowing the incoming traffic over the DB ports only from the appliances that are associated with the security group of the app, which is the app security group. And with the app security group, we have only these two instances associated. And even with these two instances associated, you are only allowing the incoming connections over a certain port that you have defined for these two databases. This could be 3306 in case of MySQL Server, and likewise for other database instances. So this is one of the example of the best practices revolving around the security group referencing. Now let's move on. Now that we understand security group referencing, let's have a quick look at another example for best practice configuration when using security groups. What we have here is a public subnet and a private subnet. So we have public and a private subnet between which our appliances are distributed. So here we have a public facing or the internet facing application load balancer. And then we have a web front-end server, which is like a front-end for serving our application layer. And then we have an internal load balancer that distributes the incoming traffic from the web front-end into the application layer. And there could be multiple servers here. And then there are database servers to which it connects, but I'm not showing you here. So now let's understand how to set this up. So what we require is that we need all the incoming connections, HTTP or HTTPS, the HTTPS connections coming from the public internet to be allowed into this load balance. And for that, we create the public ALB security group. And what we specify is that only allow HTTPS traffic to come in via port 446 and allow it from all the IPv4 address range. That means that I am allowing all the incoming requests from the internet, all sources, into this application load balancer. Now this application load balancer needs to route the traffic to the web front-end instances. So we'll have to create public EC2 security group, and what we need to do is we need to define an inbound rule, the protocol that we want to allow. So we'll allow HTTP calls over port 80, and for the source we will define the public ALB security group. That means for the source we are saying that all the application load balancer associated with public ALB security group can send requests successfully over port 80 into the appliances or the web front-end server associated with public EC2 security group. Now, in order for that to work, what we'll also do that in the outbound connection or outbound the rule for the public ALB, we'll define the protocol, and in the destination we'll define the security group associated with the target, that is the destination to which we want, which the ALBs can route the traffic. So now the traffic has reached from the application load balancer to the web front end. Now the web front end needs to call the application layer. So we need to configure the security group, private ALB security group, and define the inbound rules here to accept the incoming request from these web front-end girl. Now this application is listening on port 8080. So what we will do is that we will add a outbound rule to allow HTTP over port 8080, and in the destination we'll define the private ALB SG. So private ALB-SG will be created and it will be associated with the internal load balancer. And for the incoming inbound request, the HTTP ports over 8080 would be allowed, but the source would be defined as the public EC2 security group, which is the security group where the web front end servers are located, which are generating these requests to be routed to the application layer. Now that the internal load balancer inbound connections are configured from the internal load balancer, these inbound traffic has to be routed to the application layer. So we will configure the outbound rule to allow HTTP traffic over port 8080 to the destination, and in the destination we'll define the security group that is associated with the application layer instances, and which is private EC2SD. And here we will allow the incoming traffic over port HTTP over protocol HTTP and port 8080, and for the source for the incoming connection we'll define the private ALB security group here. So with that, what happens is that we are locking down the access to the different layer in our application, and we are ensuring that the application can talk to other components, but nothing else can. So this is one example of the best practice of using security groups and the security group referencing. So I think with this we cover the theoretical part, and you have a better understanding of the theoretical concepts around security group, but it's not enough. We need to go into a hands-on lab. So let's conclude this video here with an objective to have another video wherein we will have a hands-on session with the security group lab, wherein we are going to take a small example of this architecture, wherein we'll create a EC2 instance in the public subnet to act as a bastion host or a jump server, and we'll allow that EC2 instance to SSH into these private EC2 instances in the private subnet or private IP address, and via security groups we enable those accesses. So that's all for this video. Please stay tuned for this hands-on lab to conclude your understanding around security groups, and then we'll move over to the concepts around network access control list, followed by another hands-on lab video on network access control list, and then a comparison between network access control list and security groups. So please stay tuned, and thanks for watching. Please do like and subscribe to the video if you really find it useful.